So now I'm going to have a go at the second task in exercise 2 on Codility. It's called Dwarfs Rafting. Okay, a company of dwarfs is travelling across New Zealand. Now there's a whole story going on here, but what we need to do, we have a raft, we need to seat dwarfs on the raft. Now the raft is of a variable size. In this example, the raft is 4x4, so the size N is 4. And on this raft we have available spaces for seats, but these spaces can be taken up with barrels. Now barrels are shown as coloured squares in this example, and we're given a string S that represents barrels. So in this example we have a barrel at 1B, there, 1C, 4B, 1D and 2A. We're also given a string T of initially seated dwarfs. So we have an initially seated dwarf shown as a D in this diagram at 3B and 2D. Now we need to put additional dwarfs on this boat, and the solution of the exercise needs to return how many additional dwarfs we can seat on the raft. But we need to make sure the front and the back of the raft has the same number of dwarfs on it, and the left and the right has the same number of dwarfs. So in this example, this is the answer to this example, we can add an additional 6 dwarfs. So we had 2 up there, 1 there, 2 down here and 1 down here, and we end up with 4 dwarves in the front and 4 in the back of the boat, so it's balanced front to back, 4 on the left and 4 in the right, so it's balanced left to right. We need to return the maximum number of additional dwarfs we can sit in the boat. If it's not possible to balance the raft, the function should return -1. And other assumptions are N, which is the size of the raft, is an even integer in the range of 2 to 26. So the size of the boat is even, so it will divide equally in 2. And the range is from 2 to 26, so we can use a single letter to represent the x-axis. We need numbers from 1 to 26 to represent the y-axis, so these are not necessarily 1 digit there. Strings S, which is the one telling us where the barrels are, and T, which is the one telling us where the initially seated dwarves are, consist of valid seat numbers separated with spaces. Okay, so we know that they're valid, we're not going to have to check for overflow there. Each seat number can appear no more than once in the string, and no seat number can appear in both S and T simultaneously. Okay, so when we're told we have a barrel or a dwarf, we don't have to check that the raft has an empty space there. In your solution, focus on correctness. The performance of the solution will not be the focus of the assessment. Okay, so I'll just prepare the class and then we'll get straight into it. Okay, so the first thing I'm going to do is create a raft class. So that is an obvious candidate for just a 2D array, but I'm going to wrap it in a class so we can do things to the raft. And I'm going to add methods so that we can add barrels to the raft and we can add dwarfs to the raft. And then later I'll have a think about how I can add methods to ask the raft what the answer is. So let's first create our raft class and add our barrels and dwarfs to it. So the first thing I'm going to do is convert these coordinates into a 2D array of coordinates. So the first index in the array is going to be which coordinate we're looking at, and the second index is going to tell us the two values. But these values, I want them indexed from 0 because I'm going to use a 2D array to represent the raft. So I want to subtract 1 from the numbers, and I want to convert the b into the number 1. So a would be 0, b would be 1. So I'm just going to write a method to convert these strings into an array of coordinates. So call it get coordinates. So first thing I'm going to do is loop through. I need to split the string into individual coordinate sets. So I'm going to just split that on spaces. So I can say string array, I'll call it s-coords equals s.split by space. And that will give us an array 1b, 1c, 4b, like that. And I'm going to make the int array. This is my coordinate set. New int 2, 1 for x and y, and the length of the array will be s-coords length. Then for string s-coord in s-coords. Actually, I'll loop through with an index so I can index in coords. So int I equals 0, I is s and s coords length, I plus plus, and then string s-coord equals s-coords at I. Now the numeric part of the string, we can go up to 26. So I have 1b in this example, but I could have 26b. So I need to get the number which goes up to from the substring of 0 to 1 before the end. So int x equals s integer value of. We were told in the exercise that the coordinates are all valid. Integer value of x coord substring 0 up to length minus 1. We know that this letter here is just 1 digit because the range, or 1 character, because the range goes up to 26, so that can only go up to Z. And minus 1 to get it down to 0. And int y equals, now do this in stages, so I can say char s-coord char at s-coord length minus 1. That gives us the letter. If I cast that to an int, it will give us the ASCII value of the letter. And if I subtract a from it, if I subtract the ASCII value of a from it, that will give us the correct value. So a minus a is going to be 0, b minus a is going to be 1. So that's our x and y coordinate, and then I'm going to say s coords 0, I equals x. And s coords 1 minus I equals y. Not s coords, chords. And that should convert our string turn chords. So I'm just going to test that before going any further, just to make sure that's doing what I think it is. Here, I think I'm going to need to do this later. For in each int array coordinate in get coordinates for S system out print line coordinate 0 coordinate 1, and then I'm going to repeat the same for our T coordinate set, and just make sure that that comes up with the right answer. Now I'm just going to swap the array over, because I am going to want to loop through these. So I'm just going to swap the first index, but this is what I wanted in the first place, but I did it the wrong way around. I want the first index to represent which coordinate we're looking at, and the second index to represent the X and the Y. So I've just added that function to test now. So let's just see what it does. So let's just check that's right. So 1B is 0, 1, that's what we want. 1C is 0, 2, that's right. 4B is 3, 1. 1D is 0, 3, this is all right. 2A is 1, 0. And 3B is 2, 1. And 2D is 1, 3. Okay, so that method is working. So now I'm going to add my raft, and I'm going to do it as a class. Okay, so class raft. Okay, the most important thing in this class is going to be a 2D int array, and I'll call that cells. Now I'm going to make some static ints. So an empty cell is going to be represented by a 0, and the cells will initialize to that. We're also going to want to be able to add rafts to our cells, so I'll define a raft as being 1, and we're going to want to be able to add dwarfs, so I'll define a dwarf to be 2. Now I'm going to say public raft, I'm going to initialize it with size, and then I'm going to say cells equals new int array size by size. So we've got our square int array there. I'll also save size because that will probably come in handy later. And now I want to be able to add a raft or add a dwarf to our raft. So I'm going to add the methods add raft with X and Y coordinates, and that is just going to say cells at X, Y equals raft, and also add dwarf where I make cells at X, Y equal dwarf. So what I can do now is loop through each coordinate that I get out of this. So first I want to make a raft. Raft initialize with a size of n, and here I've got the XY coordinate. I want to say raft add raft. I want that to be not raft, this should be barrel. So I want to add a barrel for each coordinate in the S string. It doesn't really matter which one X is and which one Y is because it's a square anyway. And I want to add a dwarf for each coordinate in the T string. So at that point we should have our raft populated with barrels and dwarfs. Okay, so next I want to add methods in the raft to work out how many dwarfs we can seat, and the first thing I'm going to do is work out the maximum number of dwarfs that we can seat in each section. So in this example, in the top left we could seat 2 dwarfs. In the top right we can sit 2 dwarfs. In the bottom left we can seat 3 dwarfs, and in the bottom right we can seat 4. So we can really put a dwarf into the quarter providing there isn't a barrel there. So let's just add a method get max dwarfs for each quarter, and then we'll save those variables and we'll use it to work out the answer. Okay, so I'm going to add a private method get seats, and that's going to take min x, max x, min y and max y. And then what I'm going to do is loop from min x to max x, and loop y from min y to max y. I'm going to start off with a variable seats, and if the cells are x, y is not equal to barrel, then it's a potential seat for a dwarf. So I'll add 1 onto seats, and at the end return seats. And then this is going to be the method that's going to answer the question. So it's public, it's just going to be get seats. So I'm saving the maximum top left, and that equals the value in the top left. So the minimum x is 0, the maximum x is size over 2, the minimum y is 0, and the maximum y is size over 2. I'm just going to copy that 4 times. So top right is going to go from size over 2 to size, and the top, so the y axis is going from the top 0 to size over 2. Then we have bottom left, which is the x-axis is 0 to size over 2, and the y-axis is from size over 2 to size, and the bottom right is going to be size over 2 to size on both axes. Right, so right now the answer is going to be the minimum value between the maximum of the top left and bottom right multiplied by 2 plus the minimum value of the top right and bottom left multiplied by 2 minus the dwarfs that are already seated. So in order to balance left and right, we're going to look at diagonals. In this case we could put 2 in there, 2 in there, So we would put 2 in here and 2 in here, and the answer is 6, because so it's 8 in total minus our 2 static ones. But it did say in the exercise description that we need to return -1 if the raft is unbalanceable. And why it may be unbalanceable, so if I just clear this one off, why it may be unbalanceable is because if we put too many static dwarfs, for example, if we put static dwarf 4 down here, we have an unbalanceable boat because we cannot get 4 up there. So I'm also going to find the minimum for each of these quarters and make sure that the opposite diagonal can seat that number of static dwarfs. So the minimum is going to be the number of, when I say static dwarfs, I mean dwarfs that are initially seated. So I'm going to count the number of initially seated dwarfs in each quarter and save that, and then I'm going to make sure that the top left can take that number in the bottom right, and vice versa, and same for bottom left and top right. Okay, so I'm going to add a method get minimum dwarfs. I'll call it get min seats to be consistent, and I'm going to say if cells equals a dwarf, then I'm going to count it as a seat, and then in get seats I'm going to get our minimum number of dwarfs that we need in each quarter, and that's going to say get min seats. And at this point I'm going to say if min top left is greater than max bottom right, return -0. I'm going to do if min bottom right is greater than max top left, then return -1. And what haven't I done? Min top right max bottom left, and min bottom left max top right. So if we cannot balance the boat, we've dealt with the cases there. So now we go back to our maximum values. We can get a maximum of 2 dwarves there, 2 there, 3 there, and 4 there. So the maximum we can get in diagonals in this one is going to be 2. The maximum there is going to be 2. So we're going to add 2 and 2, so that's 4. 2 and 2 is 8, and subtract our first 2 static dwarfs to give us the answer of 6. So in diag 1 is going to be the minimum of max top left and max bottom right, and diagonal 2 is going to be the minimum of max top right and max bottom left, and then our answer is going to be diag 1 times 2 plus diag 2 times 2. Now I'm just gonna count dwarfs, so I'm gonna say int static dwarfs. Every time I add a dwarf I'm gonna count 1 there, just so I don't have to recount the static dwarfs in the array. And I'm going to subtract static dwarfs from our answer, and I think that's it. So let's see if that comes up with our answer of 6. -1. Okay. Oh, well, that's a nice simple error there. I've just left the original -1 in the solution. I just put that in there to stop the compiler warning, but I just do need to ask the Raft the question. So return Raft get seats, and let's see if we get 6. Yep, we've got 6. Okay, so I'm just going to check what happens if we give it empty strings. Right, a string index out of range. So here I'm just going to say if s.trim.length is greater than 0, then I'll add my barrels, and if t.trim.length is greater than 0, then I'll add my dwarfs, and just make sure we can cope with being given an empty string. Yeah, that's right, and that's how many dwarves we could seat in a empty boat. Okay, so I'm going to debug this, but first I'm going to add a toString method to my Raft to make it easier to debug. So in this toString, I'm going to loop x from 0 to size, and I'm also going to loop y from 0 to size. I'm going to create a string, and for each value of y, I'm going to say if cells x, y equals empty cell, then my debug string is going to consist of a space, and I put the bar just to separate it. If the cell is a barrel, I put a B, and if the cell is a dwarf, I'll put a D, and then in between each row I'll just put a row like that, and then we'll return S. So that should make it easier so that we can visualize what's in our cells. I also need to add new lines to the front and the end of those lines. So let's debug. So I create my Raft, and it's completely empty. I'm going to get the coordinates out of the S string, and I'm going to add my barrels. We can see the barrels adding into the correct positions there, and we can see that the barrels matches the diagram from the exercise description. Now let's loop through and add our dwarfs. So we have a dwarf there and a dwarf there. So those dwarfs are added in the correct positions. So now let's go into Raft get seats. The maximum number of dwarfs we could have in the top left is 2, which is right. The maximum in the top right is 2. Top right is 3. Okay, it's probably the bottom left in the diagram, but that's okay. The bottom left we have 2, so that's the top right in our diagram, and the bottom right we have 4, which is right. Then the minimum we can get in top left is 0, top right is 1, bottom left is 1, top right is 0, and top left doesn't overflow bottom right doesn't overflow top left right doesn't overflow bottom left, and bottom left doesn't overflow top right. So the diagonal between top left and bottom right, that's 2 and 4. The minimum value is 2, and the diagonal from top right to bottom left is 3 and 2. The minimum is 2. So 2 times 2 is 4, plus 2 times 2 is 4, 8, minus our static dwarfs, which is 2, and the answer is 6. So in the debugging, the diagram is not really the right way round, but it doesn't matter because it's just 4 quarters. As long as I've got the opposites in the correct position, that's okay. So I'm going to submit that and see how it does. And 100%. So that's my solution to Codility's Dwarfs Rafting. Thanks for watching.